In Science 9, we cover a variety of topics to give you a taste of what will be offered in future courses. My name is Naomi, and my partner, Madeline, and I will go through the key concepts from each unit. The units include electricity, chemistry, reproductive biology, and earth science. Let's begin with electricity. Electricity is the energy of charged particles. Protons are positively charged, neutrons are not charged, and electrons are negatively charged. Many different types of energy like solar, kinetic, and chemical energy can be converted into electrical energy. Electricity is caused by the movement of electrons. They can flow through components of a circuit. Ohm's law, V equals I times R, represents the relationship between the voltage, V, measured in volts, the current, I, measured in amps, and the resistance, R, measured in ohms. Everything that allows electrons to pass through is a conductor, and everything that doesn't is an insulator. Even humans can conduct electrons. There are two types of circuits in which electrons flow through. A series circuit has one pathway, the same current throughout, the voltage across the loads add up to the source's voltage, and the resistors increase the total current. A parallel circuit has at least two pathways for electrons to take. Also, its current through each pathway adds up to the current by its source. The voltage across each of the loads are equal to one another and its source, and the resistors increase the total current because they decrease the total resistance. There are two more important formulas to keep in mind. Power, or the amount of electrical energy used to charge into other forms per second, can be calculated using P equals V times I. Energy, the amount of electrical energy used by a device during a period of time, can be calculated using E equals P times T. And that's all for electricity in Science 9. Now, let's move on to chemistry. In the Science 9 chemistry unit, we learned how the arrangement of electrons in atoms affects its properties and placement on the periodic table. The elements on the periodic table comprise all things. Essentially, they are the ingredients to make a universe. The table is broken down into three sections. Metals on the left, which are shiny, usually solid at room temperature and good conductors. Next, nonmetals on the upper right, and also hydrogen on the upper left. They are usually gases or dull-looking solids, and then finally there are semimetals. They are found in the staircase-shaped section in the middle of the table. Generally, metals have a positive charge and nonmetals have a negative charge. There are also about 10 million known compounds that combine to form many different kinds of matter. We learned about two different kinds of atomic compounds. First, let's cover ionic compounds. They are made through sharing electrons on an atom's outermost or valence shell. It will bond with another ion with the opposing charge. There are three kinds of ionic compounds: binary with two ions from different sections, then multivalent where an ion involved has more than one possible ionic charge, and polyatomic, a covalent compound bonded with an ion. So let's talk about these covalent compounds. These bonds are made when the valence electrons are shared between two atoms to make the valence shell full. There are three different types of covalent compounds. Network, where nonmetals bond over and over again to make a network of bonded atoms. Then diatomic, which includes the hockey stick molecules bonded with themselves. And then there's binary covalent molecules, made up of two nonmetals bonded together. Naming compounds and writing out their formulas is a little tricky, so let's dig a little deeper. To name ionic bonds, you say the metal ion, then add an "ide" to the nonmetal's ending. For instance, sodium and chlorine would become sodium chloride. If a compound requires more than two ions, then you can change the ratio of each accordingly in the subscripts to balance the charges. For example, barium fluoride. Multivalent electron formulas are almost the same, except you have to choose the charge you are using and write it in Roman numerals after the metal. For instance, iron 3 sulphide. For polyatomic ions, you must identify the ions and their charges. Then you should balance the positive and negatives by adding as many ions needed to make it neutral, and then use subscripts and brackets to write the formula. For example, ammonium phosphate. Now for covalent compounds, numeral prefixes like mono, di, and tri are used in the front in order to indicate the number of atoms used. However, if the first element listed only has one atom, mono does not need to be named. Remember to still add the "ide" suffix to the end of the second word. For example, dinitrogen monoxide or carbon monoxide. Don't worry if you can't quite understand these concepts at first. Keep practicing and you'll get it eventually.
Let's go over asexual and sexual reproduction. Asexual reproduction requires only one parent to create offspring. Binary fission is when the parent duplicates its DNA and then the cell divides into two daughter cells. Yeast use asexual budding to reproduce, where a small bud grows on the side of the cell containing copies of the DNA and all the other parts of the cell also. It eventually pinches off and becomes a separate cell. Mold uses spores to reproduce. Mold grows a structure called a sporangium, and from there, spores are released that can grow into new mold. Plants use vegetative propagation to reproduce. There are many different methods of vegetative propagation, like splitting, cutting, tissue culture, simple layering, and grafting. Cells reproduce through the cell cycle, or mitosis. Here are the steps of mitosis. Interphase is when the parts of the cell duplicate. In prophase, the nuclear membrane disappears as the DNA condenses into 23 pairs of chromosomes, 46 chromosomes in total, and each pair has two copies of the same DNA. Then, in metaphase, spindle fibers guide the chromosomes as they line up in the middle of the cell. The next stage is anaphase, where the chromosomes separate to opposite ends of the cell. Then, in telophase, two nuclei form around full sets of DNA. Finally, the cells undergo cytokinesis, where the cells completely separate. Sexual reproduction needs two parents to create offspring. Male and female organisms have gametes, or sex cells with their own sets of DNA. The male sperm needs to fertilize the female egg in order to become a zygote. Within the female's uterus, the zygote undergoes mitosis and grows in stages into a new offspring. Human gamete cells have 23 chromosomes. Thus, when they fuse with the opposite gamete gender, each cell will contribute half the DNA the zygote needs. Gametes are produced by meiosis. The first stage is prophase 1, when the nuclear membrane disappears and DNA is condensed into chromosomes. In metaphase 1, spindle fibers guide the chromosomes to the middle of the cell, and then in anaphase 1, the chromosomes separate. Telophase 1 occurs when the cell divides into two. From there, the two cells undergo prophase 2, metaphase 2, anaphase 2, and telophase 2 to create 4 cells in the end, each with half the chromosomes needed to make a normal cell. Both asexual and sexual reproduction have pros and cons. Asexual reproduction only needs one parent, so it is faster but doesn't allow for variety in offspring DNA. So if the parent suffers from a disease, so will the offspring. And because sexual reproduction needs two parents, it takes a lot longer, but results in diversity that may allow the offspring to thrive in a changing environment. Thus, each type of reproduction is vital for the balance of living organisms. Earth Science in Science 9 talks about the Earth's spheres. First, let's cover the hydrosphere, aka all the water on Earth. The Great Ocean Conveyor Belt focuses on moving deep waters from ocean to ocean. This spreads thermal energy and nutrients around the world. The smaller ocean currents move water within each ocean. Now let's breeze on to the atmosphere. It holds all the gases on Earth, moving it around to create global winds. There are 3 rules that all global winds follow. Rule number 1 is that warm air rises. Rule number 2 is that cool air falls. And rule number 3 is that when air hits a hard surface, it diverges. Now, the biosphere. It includes all living things on Earth. Each organism has a role in the food chain. Plants are producers who use sunlight to make food for themselves. Then there are consumers who eat energy made or obtained by other organisms. And finally, decomposers who consume dead organisms to recycle the environment and keep energy moving up the energy pyramid. The last cycle is the geosphere, the hard, rocky part of Earth. The spheres can connect through the element cycles. The first cycle is the water cycle. I'm sure you all know this one, so let's move on to the second cycle. The carbon cycle is cycled through photosynthesis and cellular respiration. When the plants die and decompose, carbon gets released into the ground, and then eventually it goes back into the air, starting the cycle all over again. Next, we have the phosphorus cycle, the one cycle that is not stored in the atmosphere. Phosphorus can start out in rocks and in the ocean floor. Weathering causes it to be taken up by plants. After the plants die, the phosphorus is released back into the soil, where runoff, leaching, and erosion lead the element back to water bodies, where the cycle starts all over again. The last cycle is the nitrogen cycle, probably the most complicated in Science 9. Nitrogen starts in the atmosphere as N2, but bacteria and root nodules and legumes need to convert it to ammonium, NH4+. However, this is still not a form usable by plants, so nitrogen undergoes nitrification to nitrite, NO2-, then nitrate, NO3-. Now, the nitrogen is usable by plants. After the organism dies, the nitrogen returns to the soil and is denitrified back into N2 in the atmosphere, starting the cycle again. Though all these cycles are fully self-sustaining, keep in mind that since the Industrial Revolution, humans have negatively impacted and imbalanced the cycles. Humans should try to restore the Earth's balance by taking care of its cycles.
And that was our brief summary
Of Science 9.
Thanks for watching.